Assalamualaikum and very good morning. I am Nur Asila binti Yaakob from Electrical Engineering Department, Polytechnic Perdikson of Malaysia. I would like to present my research review about hybrid power system optimization applied in off-grid areas. The work is based on the review of the literature mainly published from 2002 to 2021 within the off-grid areas framework. It is organized in three sections. The first section describes the first step in optimizing the hybrid power system in modeling the individual components, which is to find the most common integrated hybrid power system in off-grid areas. Second section describes the optimal design criteria, which is one of the process of choosing a hybrid power system model. Many researchers use the assessment of economic, feasibility and power reliability in order to create hybrid power systems that are reliable and efficient. And the third section describes the optimization method based on simulation software. Electric power generation based on natural gas and coal would be depleted due to lack of supplies. Almost 90% of energy generation depends on natural gas and coal. Only 10% is contributed by renewable energy. In order to solve the issue of depletion, researchers are adopting alternate energy technologies. Nowadays, microhydro, solar PV, and wind power are the most extensively used form of alternative energy. Due to economic and technical constraints, these alternative energy systems are an attractive way for off-grid areas that have poor chances of reaching power supply from the national grid. The benefit of such energy power system are their reliability, economic, supply security, decreased pollution, and increased power quality. To meet all the benefit above, a HPS model can be used in conjunction with conventional sources like diesel generators and battery bank as storage. Such a power system should be analyzed from the optimization aspect in order to identify the integrated model of the energy power system. Upon completion of the reviews, the researcher is able to find the most common integrated hybrid power system model used in off-grid areas. The researcher is able to identify the optimization criteria that must be considered during the design process. And the last one, the researcher is able to discover a method for optimizing the hybrid power system. To achieve the first objective, the first model reviews is hybrid solar PV, diesel generator and battery system. There are three authors who describe this model with the same aims. The first one is from the LM Bali and O Zobo. He stated that the average cost of electricity and the amount of diesel fuel per year is greatly reduced with the use of multiple energy sources. The second one is from Barade and Roy. His model aims to minimize the operational hours of diesel generator loading on optimum photovoltaic penetration and the cost of energy. And this is also supported by Suanyo Azalma, developed the same model with the same objective for reducing the cost of energy. The second model reviews the combination of solar PV, wind turbine and battery system. Yang Liu categorized the model of solar PV, wind turbine and battery system into three parts: the hybrid system, the LPSP model and the levelized cost of energy model, while Tina Gagliano developed the same model with the assessment of the energy performance using the energy index of reliability. The last model of hybrid power system is hybrid solar PV, wind turbine, diesel generator and battery system. Thiru and Sauli have determined the optimal configuration of hybrid renewable energy systems to meet load demand sustainably and economically. The Homer simulation was used to examine the techno-economics of the system in Tamil Nadu, India. The findings indicate that the off-grid solar wind diesel battery configuration is the most economical for all the sites among other system configurations. Adaferetti and Bansal found that integrating PV, wind turbine, diesel generators and battery storage into a power system generation reduces power interruption and cost. The integration concept improves distribution system reliability while improving power system performance and efficiency. While Kabechi and Iption describe a standalone PV, wind, diesel, battery hybrid system with zero load energy deficit, the authors developed a worldwide technique for size optimization of a suggested off-grid hybrid power system model, a techno-economic technique based on two models, the reliability model and the economic model. These two models together can eventually discover the ideal design leading to complete system autonomy at the lowest cost. We can say that most authors who develop the hybrid power system use the economic and power reliability as a key parameter in constructing the hybrid power system. There are numerous criteria for the system cost analysis such as net present cost, NPC, levelized cost of energy, LCOE, and life cycle cost. According to Suanyo Azalma, the knowledge of investment, maintenance, operating and replacement costs as well as the salvage value is required for the LCOE and NPC criteria. And Izadia Ong evaluates the feasibility based on the total net present cost NPC and optimize the hybrid power system using Homer software. While Varade and Roy discovered the lowest cost of energy by optimizing hybrid power system. The authors state that the cost of energy is the most essential aspect in determining the optimal system design. This is further reinforced by Usman and Han developed three optimization hybrid model based on techno-economic analysis by comparing each suggested model based on the price of energy and the cost of running. Other criteria that have to be considered during design process is power reliability. There are several methods for calculating the hybrid system reliability. One of them is an assessment of the probability of losing power supply LPSP, the probability of losing load LOLP, the system performance level SPL, and the loss of load hours LOLH. Different with another method of power reliability assessment that was presented by Adifarati and Bansal. The study gives an analytical way to analyze the impact of using PV, wind turbine generator, electric storage system and diesel generator on the distribution power system reliability. It aimed to reduce the frequency and duration of power outage by using reliability index such as expected energy not supply, EENS, and expected interruption cost, ECOST. The study reveals that the aiding photovoltaic, wind turbine generator, electric storage system, and diesel generator reduces E-cost and EENS. We go to the objective number 3, which is to discover software-based method for optimizing the hybrid power system. Many studies are done on optimizing HPS systems using software tools. User-friendly software tools are necessary to make the optimization process for HPS system size more accessible. There are many commercial software packaged for modeling hybrid power system was presented by Sinha and Chandel. This PV.my is another software developed by Khatib Muhammad used for optimize array tilt angle, the inverter size and calculate optimal capacities of PV array, battery, wind turbine and diesel generator. As shown in figure from Shafiqur Rahman, the majority of publication, 82%, employ Homer and Homer Pro tools to develop and optimize hybrid power system. According to the stated research, Hoga, MATLAB and other tools are seldom used. This is supported by Sauli, state that Homer is a powerful system design tool and optimal setup is determined by the lowest net present cost of a viable device combinations. As a conclusion, this study provides an overview of the various approaches that are already in use, as well as those that are currently being researched for optimal HPS model. The model of the various types of hybrid power system are discussed here. The most common model used for off-grid hybrid power system are solar PV system, diesel generators, and battery storage. These three types of systems are used in combination with one another. The software-based method approach for optimizing the size of component in a model of hybrid power system is presented here for review and consideration. Tools such as Homer and Homer Pro are the most well-known software for optimizing the HPS system. When it comes to the optimization of the model for a hybrid power system, the most important criteria to take into account are definitely the economic analysis and the reliability of the electricity. At the end of the paper, there is a list of reference for people who want to learn more about the topic.